Stefan.
So, Rolf, are you still with us?
Yes.
And you will make an introduction, no?
Well, okay. First of all, I want to present to you all Stefan Sommer, who's been working with, we've been working together for over 9 years. I told him once we're almost like brothers because we've been in this together and sometimes we argue together and sometimes we get along very well, just like brothers do. And we were active together in Arizona in the United States. And Stefan has been, he has a very diverse background. In part, he's been a filmmaker with some award-winning films on the environment. He's also been a professor in biology. And then he's been active in the community, working as we say, pro bono, lecturing on the issue of climate change to young people, to people of faith, to people in different walks of life in the community, and has been a great inspiration for people to get involved in the issue of climate change once they understand how serious it is. So, Stefan, please feel welcome and take over on the screen, as we say these days.
Thank you very much, Rolf, and thank you, Mary, for hosting at your end. As Rolf was saying, I have been an ecologist and a professor of ecology for many, many years. And I've done a lot of different kinds of education outreach. And so what I would like to share with you all today is some basic understanding of climate change, but also talk a little bit about what is going on in Africa. And I'm hoping that y'all will join in some of that because I'm sure you know more about that than I do. So we'll talk about that, and we'll also talk about what needs to be done, what are the solutions, and how is the world progressing with those solutions. So if it's okay, I will go ahead and share my screen so y'all can see the slides.
And we see it.
So you can all see them?
Yeah, but you have, yeah, perfect. It's ready to go.
Okay, very good. So we'll be talking about the state of world climate because climate change has itself changed to moving much more rapidly since 2013. And we'll talk about that in some detail and perhaps why that might be happening. And like I said, we will talk about many different aspects of climate change. If I say anything that you do not understand or that you have questions or comments about, let's make this as much of a conversation as we can because it will be a better experience for you as well as for me. So please feel free to jump in at any moment. Yes. So this was the abstract that was put into the program. So this is basically a summary of what we will be talking about. You all are, yes?
I think we're having difficulty understanding what the question is if you want to say something.
Saeed?
Yes. Good morning.
Good morning.
Yeah. I apologize. Yesterday, network was not so good to my side. That's why I left earlier. But I think today I'll continue to be with you in this meeting. Yeah, I'm so very happy to participate in this meeting. As Lift here in Kakuma, we are now running so many activities about climate change, and that's why I would like to participate here to see where we can be connected and then work together more to handle the issue, as Kakuma is arid climate area. Yeah, thank you.
Thank you for being with us. So, as you all know, there are many things going on in Africa, and Africa is a very huge area with many different regions with different basic climate, and each of them is changing in their own way. And climate change is not constant. It affects one area differently than another, and it varies across time. So in some years, the effects of climate change might be much stronger than in others. And so there's a lot of variation. But we'll talk about a lot of this. So, and I'm sure you all are experiencing this already in your various parts of Africa. So more frequent and extreme weather events like droughts, floods, heat waves, leading to widespread food insecurity as crops fail or the harvests are less, and significant economic damages and displacement of millions of people. In the Sahel and North Africa, rapid warming, extreme heat, drought, reduced cereal harvest, tropical forest regions and savanna areas affected by altered rainfall. So there are many, many different effects, and I want to focus in on just a few of them. And I hope that I touch on the ones that you are all familiar with. Mauritania, heavy rainfall. Niger, Lake Chad basins, drought and floods, so both extremes. Niger, Lake Chad basin, so we're seeing lots of different areas affected slightly differently. Ethiopia, Kenya, Somalia, heavy rains and flooding. Somalia, protracted drought. Uganda, Rwanda, Democratic Republic of Congo, along their border, heavy rainfall. And I heard the young fellow from Uganda talking about how he was tired of the rain. He was ready for the rain to be done. And I said, please send some of your rain our way, because we have had a 20-year drought here in Arizona. Malawi, Mozambique, Tanzania, Zimbabwe, Madagascar, all experiencing many cyclones over recent years. Zambia and Zimbabwe, prolonged drought, drastically reduced cereal yields, power outages due to low water in levels in Lake Kariba, 6-year drought in southern Madagascar, South Africa, severe flooding, landslides, drought, and all of these countries are being affected in one way or another. So we won't talk about all of these in specific detail, but if anybody has any specific comments about your area, I'm eager to hear what you have to say as well. So first, some of the climate change basics. I'm sure you all know how greenhouse gases are increasing in the atmosphere and how they act as a blanket. Heat energy comes in from the sun. It warms things on the surface of the earth, and then that heat can no longer escape to outer space so well because the greenhouse gases act as a blanket to hold that heat in. So we'll talk about recent temperature rise. Earth has some buffering systems. So the climate change effects that we have seen so far could have been worse if it weren't for the Earth's buffering capacity for heat and for CO2, and we'll talk about both of those. Are we reducing emissions? We'll talk a little bit about that, what is being done, and what can you do? So first of all, the temperature record. Why do we keep long-term records? Well, so we're up here now, right? And we know what the temperatures are today, but are those unusual? Well, we don't know until we look back across time, and we can see that since 1880, the Earth's average global temperature has been rising steadily, and especially since the 1960s. The way these things are reported, the straight line across the middle here is the long-term average temperature across that entire period. And then the early years in this sequence were colder than that average, And then as time progressed, the years became warmer and warmer relative to that average across the 100 years. So that's a way that we can see that climate change is happening by looking how things are different now than they have been in the past. And I'm sure y'all are familiar with this kind of thing. Well, how do we look further back in the past? Have you all heard about ice cores from Antarctica and how we can get a temperature and atmospheric record from those ice cores? Yes? No? So we'll talk a little bit about that. Hopefully this is not too much review. So in the Antarctica, year after year, snow falls. The next layer of snow compresses that previous layer and so forth and so on. And year after year, there's another layer added. In that ice, there's a record of what the temperature, the surface temperature was of the ocean at the time that that snow formed. And the way that works is, I hope you have heard about radioisotopes. So hydrogen is an element, and the normal form of hydrogen just has a single proton in its nucleus. And so it has an atomic weight of 1. But there are isotopes of hydrogen, like deuterium. It has a proton and a neutron in the nucleus, so it weighs twice as much. So we refer to it as heavy hydrogen. There are also isotopes of oxygen. So the normal form of oxygen has an atomic weight of 16, and the isotope that commonly occurs to form heavy water has an atomic weight of 18. So when you have heavier hydrogen and oxygen in a water molecule, it takes more energy to evaporate that water molecule from the surface of the ocean so that it goes into the atmosphere to form snow. So when the temperature of the surface of the ocean is higher, you get relatively more of that heavy water evaporating, and more of that heavy water ends up in the snow, which ends up in that layer of ice. Okay, so that gives us a measure of how the surface of the ocean's temperature has changed over long, long periods of time. And we'll look at that in a moment, how far back these records go. The other thing that you can get from this ice, and this is an ice core, and you can kind of see that there are stripes in that ice core. Each one represents a layer of ice that was deposited as the snow fell year after year again. And there are some small bubbles that are in that ice. They've been trapped there since the time that that ice froze. And of course, those bubbles are samples of what was in the atmosphere at that moment. So we have a record of the Earth's temperature from the heavy water component and a record of the atmospheric composition from those little bubbles. This is a diagram of the Vostok Research Station in Antarctica. And here's all the ice. And they've taken cores in this location down to 3,623 meters. That represents about 420,000 years of layers of ice. Layers of snow that formed ice, year after year after year. The ones near the top are the more recent ones. The further down you go, the older that layer of ice, right? So what does that record tell us in terms of the Earth's temperature and in terms of the atmospheric composition across that period of time? I'm not going to show you the whole 420,000 year record, but I will show you here the last 160,000 years. And that's what that record looks like. Carbon dioxide is here on this y-axis on the left side, and change in atmospheric temperature is also on the y-axis, but on the right side. So here we see the record. This line represents the CO2 concentration in the atmosphere, again from those little tiny bubbles that are in the ice. So we can see that back here, this is the present, year 0, and it goes back through time to 160,000 years ago. Across that time period, CO2 rose like this, and then temperature rose following the CO2. So this already gives us an idea that CO2 concentration in the atmosphere is correlated with the temperature of the Earth, and that there might be a cause and effect relationship between the two. We've done many other tests that do show that there is a cause and effect. In any case, CO2 goes up, temperature goes up, CO2 goes down, and temperature declines. We just came out of the last ice age, so over the last 14,000 years, the Earth has been warming and CO2 concentrations have been going up. But you can see across that 160,000 years, the high point in CO2 concentration was about 280 parts per million. And that's what it was recently when we started just before the Industrial Revolution. So across that 160,000 years, we did see some temperatures decline and temperature rise. And that was related to CO2 concentration. But what's been happening recently? So this is just the last 2,000 years, from the year 0 up through 2016, 2020 probably in this case. But you can see that the temperature is always varying, but what's happened recently is totally different. The speed at which the Earth's temperature has risen has been very, very rapid. And this all since 1880, when we started the Industrial Revolution and started putting much more greenhouse gas into the atmosphere. Here's another graph of the same record, basically from 1850 up through the year 2023. And this is the Earth's average temperature as measured by many different instruments. And so you can see different lines from the different instruments, but basically they all say the same thing. The Earth's temperature has been rising, and it turns out that it has been rising more rapidly recently. So prior to 2013, the slope of this increase was about 0.18 degrees centigrade per decade. And since 2013, it's been about 0.26 degrees centigrade per decade. So things are rising fast. The temperature is rising faster now. Why is it rising faster now? What has changed? What is causing it to be a steeper increase? This is the same data again. This is from James Hansen and his research team. He was one of the first people to testify to the United States Congress that climate change was happening and that it could be measured. And what his is showing basically the same thing. This green dotted line is the slope of the temperature increase from 1970 or so up through 2010. And the purple dotted line is the temperature rise, best linear fit from 2010 to the present. So you can see that things have gotten faster. Why is it getting faster? Have we increased emissions dramatically starting in 2013? What is happening here? Again, that split happened in about 2013. So it turns out, and I'll show you in just a moment, the rise in our greenhouse gas emissions has been fairly steady. So our greenhouse gas emissions do not explain this steeper rise in temperature. But the Earth, as I mentioned, has some buffering capacity for temperature. And perhaps the Earth has reached the limits of its ability to buffer the temperature rise. So let's talk about all those in some detail. Okay, so here are the emissions, CO2 from fossil fuels, CO2 from land use changes. So when we cut down a forest, where does all that carbon go? Well, some of it gets burned, some of it just degrades, decomposes, and that CO2 ends up in the atmosphere. So land use itself can put CO2 into the atmosphere. We'll talk about some details of that later. So fossil fuels, land use, methane from decomposing organic material that decomposes under anaerobic conditions, methane from raising animals, and then nitrous oxide, usually from that's released to the atmosphere because we fertilize fields with artificial fertilizers, and then fluorinated gases. So we've been using a lot of chlorofluorocarbons in industrial processes, and all of those are different kinds of greenhouse gas. But was there a big dramatic
I'm
change
interrupting.
in the emissions? Yeah, Rolf, go ahead.
You may want to explain buffering. It's not an easy word or
Okay,
concept
sorry.
because it's
Good,
behind all of this that he's explaining.
good point. Thank you. So, the Earth has, so all this greenhouse gas is trapping heat, but, and I'll kind of explain this as we go through it, Rolf, but basically buffering means that there is something in the Earth's systems that is reducing the total amount of heat that we would be seeing in the atmosphere if that buffering capacity wasn't there. So it's a way to reduce the effects of greenhouse gases on the Earth's temperature. And I'll talk about that in some detail as we go here. So buffering is the ability to hold off a change. Perhaps that's a good way to explain it. Are people with me? Does that make sense? Okay, so here are emissions. They did not change dramatically in 2013. They have been rising steadily all along. And so why is temperature now rising more rapidly? This is actually the data from Mauna Loa, which is one of the peaks of the Hawaiian Islands out in the middle of the Pacific Ocean. So it's not near an industrial center. It's a place where all the gases from emission from industrial centers have mixed. And you can see that the CO2 concentration in the atmosphere is rising steadily. This is just the record from 1960 up to the present. As I mentioned, prior to the Industrial Revolution, the Earth's atmosphere had about 280 parts per million of CO2. What we have done with human emissions of greenhouse gases since then has raised that concentration from 280 to 425 parts per million as of today. So this is a huge amount of change. If anybody know what this little red squiggle might be in this graph? So the black line is the average across a year. But why does the red line of CO2 concentration go up and down like this? Any ideas? What else besides human beings affects CO2 concentration? Well, one of the things is photosynthesis. So plants take in CO2 when they photosynthesize, and they combine it with sunlight energy to change it into chemical energy. And that chemical energy is the energy that powers life. It powers the life for the plants, and it powers our lives when we eat plants, or when we eat animals that ate plants. So that photosynthesis, when in the summertime, when photosynthesis is going strong, because plants are growing in the summer, they're taking a lot of CO2 out of the atmosphere, and that is the trough. That is these low points in the little red squiggle. So these troughs, these low points, are summertime. Then in the wintertime, there's relatively more respiration. That is, all of us, plants and animals, burning up that chemical energy. And when we breathe out, we release the waste product from burning that chemical energy, and it is CO2. So in the winter times, there's relatively more respiration, release of CO2. And in the summertime, there's relatively more photosynthesis. So anyway, that's what causes this little red squiggle to go up and down. And if you think about it, and because Mauna Loa is in the northern hemisphere, that's Hawaii is north of the equator. And there's little mixing of the atmosphere between the north and the south hemisphere just because of the way things circulate at the equator. And so this is really a measure of all the photosynthesis effect and all the respiration effect in the northern hemisphere. And if you think about that, this change from one of these peaks to one of these troughs, that's the whole difference between winter and summer biological activity, right? So that's, for me as a biologist, that amount of change is huge. It's a measure of all the change in life from summer to winter. So if that is huge, how does that compare to what human beings have done to greenhouse gases just since 1960? That's this much, right? So what we have done is gigantic relative to the changes in CO2 that all living organisms combined caused to take place. So anyway, so for me as a biologist, what we've done is huge. This 425 parts per million is a gigantic increase relative to the way Earth systems work. So again, though, has there been a leap in CO2 concentration in the atmosphere associated with this 2013 change in how fast temperatures are rising? And there really hasn't been. I mean, it's rising steadily. The CO2 concentration is rising steadily, but there hasn't been a jump in 2013 that would cause temperatures to rise at a steeper rate. So again, why is temperature now rising at a faster rate? So I was talking about Earth's buffering capacity. And so let me explain exactly how those work. For one thing, the oceans themselves, and the oceans are vast. They're a huge part of the Earth's surface, right? So they can just directly absorb CO2 from the atmosphere. Now, when the CO2 dissolves into the ocean, it also causes the ocean to become more acidic. So this is not a good thing in terms of the biology of the ocean, but it is a good thing because it takes a lot of CO2 out of the atmosphere. And so we see less of a climate change effect because the ocean is absorbing a lot of that CO2 that we emit. Otherwise, climate change would be much more extreme. Also, photosynthesis, as I was mentioning, takes CO2 out of the atmosphere. So there are plants across the surface of land that take CO2 out of the atmosphere and in the oceans. So there are phytoplankton and algae of various sorts and other plants that live in the ocean that also photosynthesize and take CO2. So the oceans absorb CO2 through direct solution and through photosynthesis. Land ecosystems also photosynthesize, so they absorb CO2 from the atmosphere as plants grow and photosynthesize. But also a lot of that biological material, a lot of that carbon falls to the forest floor or falls to the ground and it begins to decompose. And a lot of that carbon ends up being stored in soils. So that's also buffering because a lot of that CO2 that we're putting into the atmosphere gets absorbed by plants that are photosynthesizing and then stored in soils. Okay, so relative to CO2 concentration, the Earth has these huge systems that give us the ability to buffer the rise in CO2 concentration. Making sense? Um, the other big buffering capacity that the Earth has is that the oceans absorb heat. So as we have raised the temperature of the Earth through these greenhouse gases, so far 90% of that excess heat that's been trapped by greenhouse gases that we emit has been absorbed by the oceans. Otherwise, we would be seeing much larger temperature rises in the atmosphere and the surface of the land and the surface of the oceans, because it's heating up the ocean. So the ocean is absorbing that heat. Everybody with me? Those are the buffering capacities, okay? So in this graph, this is just a zero line through the middle. These are all the ways in which we are artificially increasing the CO2 concentration in the atmosphere. Primarily, it's the burning of fossil fuels. But also, as I mentioned, land use changes. So when we till the soil, all that carbon that's stored in the soil, we mix it with oxygen and it decomposes faster. And so more of that carbon gets released to the atmosphere as it decomposes, as that carbon in the soil decomposes. Okay, so these are the major sources of greenhouse gases that we contribute to the atmosphere. But then I mentioned the buffering capacity. So this, and we call the ability of natural systems to absorb that CO2 that we're releasing, we call them sinks. That's where CO2 can go. These are sources of CO2, and these are sinks of CO2. So 22% of this added greenhouse gas that we add to the atmosphere gets absorbed by the oceans, both again in terms of it dissolves into the ocean, as well as there's photosynthesis going on in the oceans, and so that takes up some of that. So overall, 22% of what we emit into the atmosphere gets taken up by the oceans. 31% of what we emit to the atmosphere gets taken up by photosynthesis and soil storage on the land. So those are huge ways in which the Earth has buffered our effect of polluting the atmosphere with greenhouse gases. Does that make sense? The remaining, so you add those two up, and that gives you 53% of what we emit gets absorbed in the ocean and the land. The remaining 47% is what is in the atmosphere, and that's what's causing the climate change that we've seen so far. So again, it's really good that the ocean and the land act as a sink. Otherwise, the climate change we see would be much worse. So I've been mentioning this. The oceans absorb 30 million tons of CO2 emissions every day. The oceans are huge, and they can absorb a lot of that CO2. The problem is, and that's a good thing in terms of climate change, but it's not a good thing in terms of the ocean's ecology, because when CO2 gets absorbed into the water, it interacts with existing carbonate ions to form double the number of bicarbonate ions, and that causes the water to turn acidic. More acidic water has a bunch of different effects on living organisms in the oceans. For one thing, organisms that form shells, that include snails and crabs and a wide variety of different organisms, including some microorganisms like foraminifera and so forth that live in the surface waters of the oceans. They can no longer form shells, and then of course they cannot survive because their ecology depends on having a shell. So this acidification of the ocean is negative for all of those shell-forming organisms. And it makes it harder for phytoplankton to photosynthesize. One of the limiting nutrients in the open ocean is iron. And so the phytoplankton, these little microscopic algae, they take up iron, and they have ways to fish iron from the water. But that system of accumulating iron from the water breaks down as the water becomes more acidic. And so they can't take up iron, and they require iron in order to photosynthesize. So it reduces phytoplankton productivity in the ocean. And this is not a good thing because that productivity is the basis for the food chains in most ocean food chains. Also, those phytoplankton, because they photosynthesize, they're taking in CO2. So if they're not as productive, they don't take in as much CO2. Photosynthesis also has a waste product, which is oxygen. And it turns out that that phytoplankton productivity in the oceans produces about 40% of the oxygen that's in our atmosphere. So reducing their productivity is bad in many different ways. So we would see more climate change if it weren't for this effect, but we're also threatening the productivity of the oceans. And you can see those pH changes. They've done surveys from the south. This is 60 degrees south to 60 degrees north, the equator in the middle. And you can see that measures of acidification. The more red it is, the more acidic that water is. Yellow, a little bit less acidic, green, a little bit less acidic, and blue is the normal pH of the ocean. But near the surface, in the Indian Ocean, again, from this survey from the south to the north, we see huge areas of the ocean surface waters that have gotten fairly acidic. In the Atlantic Ocean, same thing. From the south to the north, all of this surface water is becoming acidic. And not surprisingly, because many of the industrial centers are in Europe and in North America, we see more of that acidification in the northern part of the Atlantic Ocean than we do in the southern part. In the Pacific Ocean, they took this survey way out in the middle of the Pacific Ocean, so there's less of that industrial effect, but yet because we're increasing the CO2 concentration across the entire atmosphere, we are still seeing some acidification out in the middle of the Pacific, again, from south to north along this transect. So I've been mentioning that land ecosystems take up atmospheric CO2 because plants photosynthesize and they use it as a raw material. And then some of that carbon is in the living plants, and some of it are branches that break off, trees that die and fall over, and they start to decompose, and that carbon ends up in the soil. So the soils store a lot of that carbon. The land ecosystems can take up as much as 785 million tons of carbon every year. So that's a lot of carbon being taken out of the atmosphere by ecosystems on the land. And the soil stores, and between the two of them, all the vegetation and what's in the soils, that's over 3 trillion tons, 3,000 billion tons of carbon is stored in the plants and the soils. So that's huge. We look at the Amazon, and in the past, the Amazon, because there are so many plants and they're photosynthesizing, it was a huge sink for CO2. The Amazon absorbed a lot of CO2. But since about 2018, the Amazon is no longer a carbon sink, it's now a carbon source. And there are two reasons for that. One is you see all these fires, they're clearing the forest and they're burning a lot of that material to open up new agricultural land. That releases the CO2 quickly back into the atmosphere. But also, and even a bigger effect, is that the climate is changing. And so the climate in the Amazon, which used to be ideal for tropical rainforest plant species, is now more like the climate in savanna type of regions. And these plants are no longer ideally adapted to the climate conditions, and so their productivity has dropped. So they're photosynthesizing less and absorbing less CO2. The second largest tropical rainforest is the Congo Basin. And it still is a carbon sink during the wet season, but it's already on the edge. It's teetering on the edge. It's now become a carbon source during the dry season. Overall, it holds about 66 billion tons of carbon. And during the dry season, it releases more of that carbon than it absorbs, mostly because of the forest and peatlands burning and being cleared, because a lot of that carbon that's in the Congo Basin is stored in peat, which is slowly decomposing wet organic material that accumulates, but it is now starting to release more of its CO2 as the forest gets cleared, as that land dries up. And again, just like in the Amazon, tropical plants are less productive as climate change changes the climatic conditions. In the case of the Congo Basin, one of the big things that have changed is that overall, and I'll show you this record in a second, there has been less and less precipitation. I know y'all are right now, you're getting lots of precipitation and you're thinking, no, precipitation hasn't reduced. But again, that's why we need to take careful records. And fortunately, we've got the Yangambi Research Station in the Democratic Republic of Congo. There were rain gauges installed there in 1928, and the data showed that rainfall has been dropping since the 1960s. Here's that data. I know right now there's a lot of rainfall at this moment, but overall this year there has been less than there was the previous year, and so forth, back through time. And that change in rainfall lowers plant productivity, means that there's less CO2 uptake. The Congo Basin is now less of a CO2 sink because there's less rainfall overall. Everybody with me? Okay. The same thing is happening in ecosystems all over the world. And for us here, this is the state of Arizona that I live in the United States. And I'm showing a blow up of the 3 northern counties in Arizona. Coconino County is the county I live in. There's Navajo County and then Apache County. And the X there marks the approximate location of where Flagstaff is. But these satellite data from 2018 show that we had seen more than 80% drop in the production of rangeland plants across this area. All the areas marked in red had less than 80% of their normal productivity. Some of the other areas were less heavily affected, but still 50 to 80% drop in productivity. So this is happening all over the world. In our case, it's happening because we have more variable precipitation, because we have higher temperatures, meaning that there's greater amount of evaporative loss. More of that moisture evaporates because it's hotter. And also because we used to always have spring winds, and winds help to dry out the landscape. But now in addition to the spring winds, we now have strong fall winds. And this is what the ranching community, Jim Babbitt is from a big ranching family here in northern Arizona. And he was telling me that we now see fall winds that are drying out the range. And so they have to haul more water and more hay all through the fall and the winter to keep their cattle alive. Anyway, it also means that these rangelands are less of a carbon sink, right? So the Earth's ability to buffer that CO2 keeps dropping as we change the productivity of the land and of the ocean, the photosynthetic productivity. So in terms of heat, the oceans, as I mentioned, have been absorbing 90% of that excess heat trapped by greenhouse gases. And this is just a record of the ocean heat content since 1960. And this is the amount of heat content in the top 2,000 meters of the ocean. And there's a little bit less in the top 700 meters just because there's less water. So it's holding less heat. In any case, though, the oceans have been absorbing a lot of heat energy. And this is measured in zeta joules. Zeta means it's 10 to the 21st joules. That's a huge number. And you can see the number down here. A 1 zeta joule equals whatever this number is. I don't know, I'm not even sure what the name for it would be. So many places and zeros of British thermal units, if you know that measure of heat. So this is a lot of heat energy. We have warmed the top 2,000 meters of the ocean now. And this is not good. Warmer oceans do not support coral reefs. Our coral reefs are bleaching because of that higher temperature, and it's affecting ocean ecosystems in many different ways. Just as ocean acidification also is affecting ocean ecosystems. This is another way of looking at that same heat. So again, this is a record from prior to 1960 up to just about the present, 2023. And this is the long-term average across that time period. Prior to 1997 or so, temperatures were in the ocean were lower than that average. And since then, they've been higher than that average, and they keep increasing because the oceans have been absorbing more and more of that heat. The question is now, is that we know we've reduced the buffering capacity that the land has for CO2 concentration because there's less photosynthesis. But is the ocean losing its ability to take on that excess heat? Well, this graph itself does not indicate that, but this does. So starting in 2023, we've had long-term records of what the global ocean surface temperatures are. And you can see year after year, there's slight rise in ocean surface temperature. But this red line, the bright red line, is the record from 2023. And you can see something happened here. In 2023, suddenly there was open space between the temperature of the ocean surface that year and all the previous hot years. So there was a dramatic increase in ocean temperature, and that a dramatic increase in went into 2024. So I don't know what has caused the global sea surface temperatures to jump like this, but it suggests that maybe the oceans are reaching their limit for taking on that heat energy. Certainly, if the ocean surface is hotter, there will be less transfer of heat from the atmosphere down into the ocean, just because it's hotter and there's less temperature difference between the ocean and the atmosphere. In any case, this might very well be the primary reason that we're seeing a faster rise in the Earth's temperature, is because the oceans are reaching their limit for buffering that temperature increase. Okay, so this is from a presentation by Johan Rockström, who's the director of the Potsdam Institute in Germany. He's a climate scientist who looks at the long-term record and what it might imply for sustainability on Earth. And if you look at this, that the time scale is different in these three blocks. So this is 100,000 years, 200,000 years, 200,000 years. In this time block, each of these this is 10,000 years and this is 20,000 years. So, and then in this scale, this is just 150 years, 150 years, 150 years. So you got to keep that in mind, that the time scale has changed across this graph. But since human civilization began, some, whatever it is, 13, 14,000 years ago at the end of the last ice age,
Najaribu
Yes.
kuhanda hawa wasee walete kazi tuwarekodie video kibonga.
Migori? Okay. He didn't know he was on. Okay, so we came out of the Ice Age, and civilization as we know it today, with agriculture and all these things, developed across this time period from 14,000 years ago up to the present. And during that time, here's been the temperature range on Earth. So Dr. Rockström refers to this as the corridor of life. These are the temperatures within which we have developed our agricultural systems and our current society. We are about to leave that corridor of life. So here we are, 2013. Since then, temperature increase has gotten steeper, and we are projected to reach about 2.7 degrees centigrade warming by the year 2100. And we will be well outside of that corridor of life, meaning we are going to be in very different conditions for agriculture, for productivity of plants on the land, in the oceans, and everything, because climate affects everything. So this is scary to me as a scientist. This is a very scary thing. We do not really want to leave this corridor of life, and we need to do everything we can to not leave this corridor of life. Okay, so what have we done so far with climate change? What are we doing to the climate? Basically, we've added greenhouse gases to the atmosphere. They trap in more heat, so we're adding more heat energy to the atmosphere, to the land surfaces, to the ocean. And what we're doing is we're giving, and that's where all our weather systems are. We're putting more heat energy into the weather systems. And so what can we expect? Well, we can expect more extremes. I've put the Earth in this orientation not for any geopolitical reasons. I've put it in here so y'all can see this face, Old Man Wind. This is the most commonly used picture of the Earth from outer space. And you can see him here. There's an eye, here's his nose, here's his howling beard, and a wisp of hair. Can you all see Old Man Wind? What we're doing by adding more heat energy to the atmosphere is we're giving Old Man Wind that much more energy to howl up a storm, right? And that's what we're seeing. We're seeing more storms. We're seeing more extremes in the weather of every kind. This is a plot of billion-dollar weather disasters in the United States from 2017 up through 2024. Each of these years, have been more and more of these billion-dollar climate disasters. And so we're seeing the data reflect that we're seeing more weather extremes year after year after year. This is another graph. That's for the United States alone. This is a graph that looks at all of those climate disasters, they call them natural disasters, across these years, and how they've been increasing over time. And this includes the droughts, floods. Earthquakes have not really been changing in how many there are per year because they're not affected by climate. Extreme weather, more. Extreme temperature, more. Volcanic activity has not really changed because it's not affected by climate. Wildfire has increased, glacial lake outburst flooding, dry mass movement, that's when you get landslides, or wet mass movement, when there is moisture in the landslide. So we're seeing more and more of these climate disasters around the world, not just in the United States. And these climate extremes are now affecting agricultural productivity. So over $21 billion in crop losses in the USA, both in 2022 and 2023. So these are significant crop losses. Globally, over $163 billion in crop losses, as reported by the United Nations Food Food and Agricultural Organization, FAO. And there are many such examples of losses in Africa. So for instance, in 2019, it was reported that the yield for millet had dropped 10 to 20%. The yield for sorghum had dropped 5 to 15% because of climate effects. And this cost the economies in those countries that produce millet and sorghum significant amounts of money. I will make this presentation available to anybody who wants it, and so you'll be able to follow these references that are in here. And I'll give you my email address at the end, so if you want to get any of these papers that I'm citing in this presentation, I can send them to you. This is a report about the effect of climate change, the projected effect of climate change by the year 2100 on 6 crops that are important in Africa. So for maize, there are some regions that will actually see increases in productivity, but most areas will see a drop in the productivity of maize, serious drop in the productivity of soybean, and drop everywhere in the productivity of rice, and most areas dropping in the productivity of wheat, most areas dropping in productivity of sorghum, as well as cassava melons. So this is already affecting agricultural productivity in Africa, and it's expected to have stronger and stronger effects as things continue to heat up. This map, and again, when you get a copy of this presentation, you'll be able to go to this interactive map, and you can click on any one of these octagons and find out the story. So when I clicked on Nigeria, this is from May 2024. They had been affected by a mix of drought, rain, and floods, and it was impacting their crops of okra and potatoes. And so please do ask for a copy of this presentation and follow these links if you want to explore how specific areas are being affected. For us, and it's not just Africa, this is happening all over the world. For us, one of the big issues is that there's an area in Central America, here in this area, between North America and South America. The countries of Guatemala, Honduras, and El Salvador are part of this region called the Northern Triangle, and it has been affected by very severe drought. In the lowlands, this has affected corn, maize, and beans, as well as melon productivity. And so the farmers are struggling. They cannot produce enough crop to feed their families, let alone to stay in business. In the highlands, where they grow coffee, there have been shifts in the seasonality of rainfall, and that has brought in a variety of new coffee diseases that have greatly reduced the productivity of the coffee harvest. So it affects people in different ways in different areas. This is what the corn crop looks like in drought-ridden Guatemala, El Salvador, and Honduras. They've lost huge areas to this drought, and people can no longer survive there, and they're starting to flee. This is a picture of the lines of people who are fleeing those 3 countries. And over 7,000 refugees crossed the border into Mexico in 2018 from Guatemala alone. The U.S., they have problems when they get to the Mexican border. Mexico doesn't want to let them in. Then they get through Mexico if they can, and they come to the United States, and they are also blocked from entering the United States. So these people are not leaving their homes just on a whim. They're leaving their homes because they can no longer keep their business going or can no longer keep their family alive. So this is a family that is fleeing from Honduras specifically into Mexico, and they meet the Border Patrol. This is a family from El Salvador that made it to the U.S. border. And again, they're being stopped and arrested in many cases. So, and in this case, the Border Patrol threw tear gas, and this mother is fleeing with her children. There was a study in the medical journal The Lancet in 2016 that looked at how will this reduction in agricultural productivity affect human survival, just as a result of how that change in productivity will change human diet, what people can eat. And they projected that just from the diet effect of this reduction in agriculture, we can expect an additional 529,000 human deaths per year, just from that alone, by the year 2050. And there was a range of outcomes in their projections, and it could be the median projection was for 529,000 deaths per year, but it could be as many as 1 billion deaths per year, depending on the details of how this drop in agricultural productivity plays out. This is not good news for the world or for us. So what can we do? We need to avoid that outcome with everything we have. We need to reduce our carbon emissions, and we need to focus on our individual carbon footprints, but also our collective carbon footprints. What do the companies that serve us put out? What do our cities put out where we live? What do our countries put out, and so forth? So individual and collective carbon footprints both need to be reduced. We need to stop burning stuff, because that's one of the main ways that we get CO2 out in the atmosphere. Particularly, we need to stop burning fossil fuels, but we need to stop burning stuff in general. We need to clean up the electrical grid. As we clean up the electrical grid, we need to shift away from combustion engines and other fossil fuel furnaces and that kind of thing, and move to electric vehicles and heat pumps. And we'll talk a little bit about lithium mining. And then one of the big things we can do, we mentioned earlier that land use is a big source of carbon for the atmosphere. And regenerative agriculture is a way to address that. And that's a big thing in Africa because many people are already doing it. And it's part of the traditional farming practices. So we need to reduce emissions rapidly. This is from the IPCC report of 2018. The IPCC is a United Nations body of scientists. It stands for the Intergovernmental Panel on Climate Change, and they review all the research on climate change and make reports every year or every couple of years. And this is the year after year emissions, the annual emissions of CO2. And at the time, in 2018, they were saying, and here's what we need to do if we want to avoid raising the Earth's average temperature 1.5 degrees centigrade. We need to drop our emissions to zero by 2040, and that looks like this. So basically reversing what we're doing now with CO2 emissions, or at least by the year 2055. If we reverse our emissions to zero by the year 2040, then we will have put this much CO2 into the atmosphere, about 2,600 to 2,700 gigatons. That's billion tons. If we don't reach that net zero goal until 2055, then we will have put almost 3 trillion, that is 3,000 gigatons of CO2 into the atmosphere. And this, we would be above 1.5 degrees centigrade warming, and this would not be good. So we will reach 1.5 degrees centigrade warming when we have put 2,900 gigatons of CO2 into the atmosphere. And we are rapidly approaching that. In 2018, they were projecting that that would occur somewhere around the year 2040. Unfortunately, they've made new projections that put that problem much closer. In 2020, we had already put 2,400 gigatons into the atmosphere. Again, we'll reach 1.5 degrees centigrade warming once we put 2,900 gigatons into the atmosphere. That means we could only put in another 500 gigatons above what we'd already put in 2020. In 2020, we were already emitting 59 gigatons of CO2 into the atmosphere every year. If you calculate how many times does 59 go into 500, well, not very many times. That suggests that we will reach 1.5 degrees centigrade warming sometime in the year 2028. So this is right around the corner. So the time to act is really yesterday, but since we didn't act yesterday, we got to act today, right? So the good news is that the European Union has already set net zero goals. Unfortunately, they set their net zero goal at the year 2050, and that's not soon enough. But countries like Great Britain have already reduced their CO2 emissions to half of what it was in 1990. So it can be done, and some countries are doing it. This is the good news. We need to urge them to move more rapidly, but they're showing that it can happen. In Arizona, our own electricity company, our utility that provides us with electricity, has recently set the goal of being net zero by the year 2050. This is a good thing, but again, it's not soon enough. In Flagstaff, the Northern Arizona Climate Change Alliance, us, we have pushed the city to develop and approve a climate action and adaptation plan. They did this back in 2018. And we got them to declare a climate emergency where they set the goal to be net zero by the year 2030. They did that in June of 2020. And then they developed the carbon neutrality plan, which gets a little bit more detailed in terms of how to reach net zero by 2030. I just wanted to point this out since this is a youth summit. Many people are acting in many different ways. This group of young people got together and they sued the state that they live in, the state of Montana, saying that the state constitution guarantees a healthy living environment for its citizens, and therefore they cannot continue to pollute in the way that they were polluting. The judge ruled in their favor, and so now the state of Montana is having to reduce its carbon footprint because of what that judge ruled. So we can, attack this in many different ways. For the Northern Arizona Climate Change Alliance, we have 14 different climate action teams that work on different aspects of the carbon footprint that a city of Flagstaff puts out. So there's a group that's working to make streets safer for bicycles. There's a group that's working to push the city to implement its policies for net zero. There's an educational group that reaches out to people and helps them understand about climate change. And all these different things. We have a radio show that we put out to help people understand many different ways in which people are addressing climate change. Another bit of good news, well, there's a lot of good news, and this is sort of a summary of some of it. Solar energy is rapidly increasing, so the global economy is changing. Renewables dominate all new growth in energy production. Solar and wind are the cheapest ways to generate electricity and have been for about 7 years. 90% of new power being installed, that is electrical generating capacity being installed, is solar. 90%. So this is good news. Solar now provides about 2 terawatts of the electrical demand in the world. Wind, 1.1 terawatts. That's 1,000 gigawatts. Clean energy employs more people than fossil fuels. European coal consumption is down by 61%. California, the neighboring state here to Arizona, was powered 100% by renewable energy for 100 days last year. Is all this good enough? No, but it's a big step in the right direction. So here's what's happened to the cost of electricity from solar photovoltaic. The volume of solar photovoltaic production has increased, that's the blue line, and the cost per kilowatt has declined, that's the orange line. For concentrated solar power, same thing. The implementation of that has increased and the cost per kilowatt hour has decreased. For wind power, more and more wind power is being put in and the cost has dropped. Offshore wind power, same thing. More and more is being deployed and the cost is dropping. So these are good things. Solar and wind electricity are now less expensive than fossil fuel generated electricity. And so the market will get more and more of this kind of solar and wind generation installed. Here's a cost comparison. This is just for the United States alone. But the cost per kilowatt for gas generated electricity is here, coal, gas and coal, and that's gas with carbon capture, coal with carbon capture. This is just gas and coal generating electricity straight off. Offshore wind is more expensive than some of these other renewables, but it's still cheaper than coal. Photovoltaics of different kinds are also cheaper, and onshore wind power is the cheapest of all of them. So this is good news. This means that businesses will now choose to install wind and solar power when they have the option to do it. In the United States, in 2024, the production of electricity from wind, that's the blue line, actually surpassed the production of electricity from coal. So we now have more wind generated electricity than we have coal generated electricity in this country. It's not enough again, but it's a step in the right direction. This is a map for percentage share of electrical generation from non-biomass renewable sources all over the world. And the darker the blue, the higher the percentage of electricity in that country coming from renewable wind, solar, and hydro type of power. You can see that many of the African countries have a very high percentage of renewable energy in their energy mix. And this is a good thing. I looked specifically at all these various countries, and the main reason that they have a high percentage of renewable energy is because of hydropower. So many of these countries get most of their electricity from hydropower. Lesotho in South Africa gets hydropower, but also a good bit from solar power. Kenya, from what I've seen, they get a lot of energy from geothermal as well as hydropower. Uganda, hydropower and other renewables. Zimbabwe, hydropower and coal power. So they didn't get quite as dark of a blue indicator for their percentage of renewables. Not quite as high. So you can see that many of the African countries are doing quite well in terms of cleaning up their electricity production. So again, globally, we've got over 2,000 gigawatts of solar power. Sub-Saharan Africa has recently put in a project with 125,000 homes that have small photovoltaic power. South Africa has put in many power plants like this, altogether about 2.6 gigawatts of electricity production. Ouarzate power plant in Morocco and Danzi power plant in the Central African Republic. So many of these countries are putting in wind and solar power. And you can see here, this is annual increase in solar power generating capacity. So overall, over 2,000 gigawatts worth. And this is how much got put in 2023, 2022, and so forth. The rate of building this solar power is going up. For global wind, we've got, again, 1,100 gigawatts of wind power, including in Kenya and Tanzania. And here's a map of 10 of the largest wind power plants across Africa. And again, globally, the capacity for generating electricity using wind has been increasing steadily and faster and faster. In the United States, we still have natural gas producing more of our electricity than renewables, but the renewables are increasing and the distance is not as big as it once was, and renewables are producing more than nuclear and more than coal. The breakdown is most of this is wind, some of it is solar, a more steady component of hydro, and much less biomass and geothermal, but these are all clean sources of electricity. Here around Flagstaff, we've had a lot of different wind power plants put in recently. This is a Chevelon Butte wind power plant to the east and south of Flagstaff. It's going to be a 477 megawatt plant, and they have been building it for a little over a year now. Altogether, we've got the Dry Lake Hills wind power plant, the Perrin Ranch wind power plant, the Breck wind and solar power plant of 241 megawatts, the Chevelon Butte wind power plant of 454 megawatts of wind, and Cobar Solar 480, for a total of over 1,400 megawatts. Megawatts, 1.4 gigawatts. So this is a good thing for our region and a good reason for us to move away from gas furnaces and gas combustion vehicles and move to electric. Sometimes people say, well, we can't put in all this wind and solar because it messes up the landscape. We've got all these photovoltaic panels covering the ground. We've got all these wind turbines and they screw up the view. Well, in reality, those complaints are very, very superficial and have no basis, really. If we powered the entire world's electrical needs with solar, those solar power plants would require less than 1% of the land surface area of the Earth. For wind, same thing. If we powered everything, all the electricity the world consumes with wind, it would be less than 5% of the land surface area. So the time to go electric is now. I don't know what level of electrical cars you all might have access to, but this is not the only option. I just did purchase my first electrical vehicle, and it was a VW Buzz. China is now producing much less expensive electric vehicles. So BYD is one of the largest electric vehicle producers in the world now. So I don't know if you all have access to those, but many, many more varieties of electric vehicles are becoming available. Of course, walking, biking, and non-fuel cars are much cooler than electric cars because you don't need to generate any electricity at all for them. Instead, it's human power in the case of these things. Or I love these. So this is another kind of non-fuel cars that are even better than bikes and walking, right? Anyway, I found these interesting to see how people use their old vehicles that are no longer burning fossil fuels. We had a student competition where the students designed a vehicle, human-powered. This is basically a bicycle car that won a race. So they did a good design with this. So these kinds of vehicles can not only burn less fossil fuel, but also be fast. And in Arizona, we now produce a variety of different electric cars. So Phoenix Motor Cars produces a variety of different trucks. Lucid Motors produces a sedan that has a 500-mile range. And Chevy is now producing five varieties of the Silverado, which also has a 500-mile range. And Nikola Motors produces hydrogen trucks. They're a combination of battery-powered and hydrogen-powered. and their Badger pickup was designed to have a 600-mile range. So things keep advancing. Some people are concerned, well, you get an electric vehicle and it also has a big carbon footprint. Well, it does initially have a slightly larger carbon footprint than the production of a combustion vehicle. But even by the end of the first year of operation, the combustion vehicle has a much higher carbon footprint, and across the entire lifespan of that vehicle has a much higher carbon footprint than an electric vehicle. So electric vehicles are much cleaner. The prices for electric vehicles are dropping. This is a good thing. They need to drop further, and they will as more and more people buy them. And they also, as more and more people buy them, the price for the lithium batteries in those vehicles keeps dropping. My son is now working for an engineering company down in Tucson, in the southern part of the Arizona state, and they have come up with a new design for lithium batteries that takes less lithium, and so they can store about 10 times the amount of energy, electricity, per gram of lithium that they put into their batteries. So there are people working on these developments in many different ways. Just look at this bottom one. The sales of electric vehicles has increased since 2019, has increased by 385% in the United States. And the sales of combustion vehicles has dropped by 14% across that same time period. So electric vehicles are selling faster than combustion vehicles in the United States now. There's a lot of worry about all the different minerals that are required to produce an electric vehicle. So do we have enough? And it turns out, yes, we do have enough. The amount of lithium required, we have reserves that are more, and we have the potential resources as we keep looking for places to find lithium. There's a huge potential for finding more. For copper, cobalt, same thing, graphite, neodymium, and nickel. All of these things, we have plentiful supplies. And really, we have a lot of these materials in our landfills. We probably should be mining our landfills for some of these things that we have thrown away. So overall, because of potential resources being huge, we have plenty of these minerals available for the production, for the electrification, not just of vehicles, but of everything. And so people are worried about the mining. And yes, lithium mining has some significant issues. There are very abusive mining practices for people who are mining lithium, and those need to be changed immediately. There are very dirty mining practices, and those need to be cleaned up immediately. But overall, for all the materials that we would need to change the economy to all electric, it would require 300 million tons of mining by the year 2050. You compare that to the amount of mining that we do for fossil fuels. By 2050, we will be mining, 15 billion tons of material from the earth in terms of coal, oil, gas, and so forth. So there's much more mining associated with fossil fuels than there is with all this electrical development. Heat pumps are a very efficient way. I'm looking to change my gas furnaces in my house to heat pumps because they're all electric and we have a much cleaner electric supply coming online. Heat pumps are broadly used across Europe, so sometimes people worry that they're not as good as furnaces, but they are. And most homes being built today in Europe are being built with heat pumps instead of gas furnaces. But another huge component that we all need to get involved in is regenerative agriculture. So the way we do modern agriculture with this big equipment and so forth, we're basically tilling the soil. We do it every year or sometimes multiple times per year. And when we're doing it, again, we're mixing oxygen in with all that soil carbon. We're speeding up the rate that it's degrading and speeding up, because it degrades, that CO2 gets released to the atmosphere. So this kind of agricultural practice is not good for the world. It also depends on a lot of pesticides and artificial fertilizers and produces overall less healthy food. So in the United States, we're pushing for farmers markets and more organic farming, where farmers are actually building soil fertility. And they build it by putting more of their excess harvest and more carbon material, manure, and so forth back into the soil rather than just tilling it and putting in artificial fertilizer. So worldwide, soils hold over 2,000 billion tons. That's 2.3 trillion tons of carbon in the top 2 meters. That's 5 times the amount of carbon in all the vegetation on Earth. So if we change our agricultural practices in a way to keep that carbon in the soil or put more carbon into the soil, we can greatly change that footprint of our agriculture from being a large footprint to being small or even being a negative footprint. That is, it could absorb more carbon than it releases. And these are just examples of permaculture, no-till agriculture, and those kinds of practices that keep more of the carbon in the soil. These are United States examples, but these are some German examples. So in Germany, they have some of the blackest, richest soil I've ever seen. My family is from Germany, so I go back and visit relatives. And the land smells rich and fertile because they take all of the waste from one year's crop, put it in these horizontal bunkers or silos to ferment over the winter. And then they put that fermented material, along with manure and other things, back into the soil prior to planting. So they're putting much more carbon back into the soil than we do with modern agricultural practices like in the United States. So sometimes the older ways are better. In Africa, this is a report on regenerative agriculture in Africa. There are many different forms of regenerative agriculture, and overall, this report found that regenerative agriculture could store 4.4 gigatons of CO2 per year in the soils just in South Africa. And one of those aspects of regenerative agriculture is the planting of forests, agroforestry. And that could store as much as 106 megatons of CO2 per year. So there are ways that we can take more CO2 out of the atmosphere and stop dumping as much in the way we change our land use practices. One of the really neat things that I've learned about from a fellow faculty member here over the years is the seed schools in Zimbabwe. And as climate change affects all of the conditions, the timing of rainfall, the amount of rainfall, all these different things, the temperature, so forth, we probably will need different crop species. Well, in Zimbabwe and probably many parts of Africa, there's a vast traditional knowledge about different kinds of crops that can be grown in different conditions. And in these seed schools, people get together monthly. Each farmer knows how this particular seed grew and that this one grows really well next to that one. This one grew best in the driest spot on my fields. This one grew best in the wettest spots. They know these things. And they exchange that information when they get together every month, and they exchange some seeds. And so that's how that knowledge adapts the farming practices to the conditions of the climate in that particular location. And because they have this variety of seeds, they have some potential for dealing with the new conditions that climate change will bring. And this is a really valuable resource, maybe more valuable than any other land use resource, is that knowledge of the seeds and how to use them. And it has great results. So traditional farmers know their seeds and they can make very good use of them. I'm going to skip some of this part. And so overall, there are many, many ways in which we can fight climate change, reducing our individual and collective carbon footprints. John Kerry, who was a vice president here in the United States a few administrations ago, typified this as, since we're all trying to reach net zero, he called it World War Zero. And he called it that because in big wars, countries mobilize all their resources for winning that war. Since this is such a huge issue for life on Earth, we need to put all of our resources into fighting climate change and into reaching net zero as quickly as possible.
Stefan,
And we can do this in many different ways. Yes, Rolf.
yeah, let me interrupt briefly. I've been told that in about 18 minutes, they're going to begin some building which will disturb the sound system. So I
Okay.
would urge, if it's possible, to encourage questions as soon as you can.
Yes, this is the last slide, actually.
Yeah, I think you're tying up, but we may not be able to hear everyone afterwards after 11
Yes,
o'clock. And my apologies because I was not aware of this earlier. Yeah,
no worries. So I'm just about done.
thank you.
So I mentioned these earlier. These are all our climate action teams here in Flagstaff. You can model these kinds of climate action teams in your own communities. Some of these might make less sense in your community, some of them might make more sense. But if you have ideas within your community for what you can do, I would suggest that you start organizing and building your own climate action teams, whether they be tree planting climate action teams, and I know you guys are going to do a field trip for that today, or a seed bank climate action team, or a fleet electrification climate action team, whatever it might be that would make the most sense in your community. Please organize and get moving on these things because we're falling behind the curve. We need to change our carbon footprint as rapidly as we possibly can. If we don't, we'll see this. Each turn around the circle here is a year. You can see the months around the outside, and as these are the temperatures. So year after year, the temperature keeps getting higher, and you can see two things. Year after year, not only does the temperature keep getting higher, but the rate of increase of that temperature keeps getting faster. We want to avoid that outcome. So if you want to find out more about what NASCA does, please visit these sites. If you would like any of this information or have any questions for me after we're done with the question period next, this is my email address. Please feel free to reach out to me. I can send you the papers that I cited. I can link you to a copy of this presentation because I would like you all to become climate ambassadors in your own communities. Not just organize, but also educate. Reach out to people with this understanding of climate change so that everybody can get on board because we need everybody to really accomplish this net zero goal. So thank you all very much for being here today. On behalf of the Earth, thank you very much for your good work on climate change. And I'll be happy to answer any questions that y'all might have.
Okay, thank you. Yeah, thank you very much. If there's any question from the floor, we can take them up because the time is on our side. Some event is about to start. There is a lot of news. So is there anybody who has any question according to the presentation that has just been done?
Thank you. Thank you for the nice comments in the chat. And put any questions in the chat or just speak up. There are not so many of us.
You have a question here?
Yes.
Good morning, everyone. Okay, the presentation was very fantastic, and my concern about Kenya, about the fertilizer which the government bring to us, it was it was not functioning. Some of us went to agrovet to buy those fertilizer, but not by opening that bar, on that maybe it is us. So I don't know, because even like Namtoi down there, Kapsote, normally we use maybe organic manure, but when we use this fertilizer, you find that the soil has been acidic. And
Ah,
I just wanted you to maybe to mitigation, which mitigation we might have, or intervention which we might use so that we come up with good fertilizer which can help us. Thank you.
well, very good. And so when you experiment like that, if the fertilizer makes it too acidic, then I've seen what when I was a child, we had large gardens, and we would let our manure sit longer, and that would reduce that acidic effect because it decomposes over time. And so I think in Germany, it's the fermenting process that reduces the acidity, but you might find some way of letting the manure sit longer or ferment or something so that you can still use it without the acidification thing. Right now in our country, we also have a government that is not cooperating with what we need to do. So we also want to mobilize the vote and replace the current government in the next election. Anyway, sorry, go ahead.
Okay, I had a question here. Even with this natural breathing cycle, the long-term black line keeps on climbing, showing that the human emissions are overwhelming the natural balance. So what are we going to do about that?
Well, that is the central question. So yes, thank you for the question. We can address it in these ways. We need to reduce our emissions, but also we need to figure out ways that will take more of that CO2 back out of the atmosphere. And farming and growing trees, those are very important because they do take CO2 out of the atmosphere. You know, I don't know if we can do enough of it, but we need to try.
Okay, thank you.
Thank you. And thank you for the field trip you guys are about to do. So, you know, planting trees, that's at the core of so many parts of this.
Okay.
Just a short statement, which I find interesting, that Africa is really on a great path to renewables at the same time that the people of Africa are being subject to the horrific emission increases that are coming from outside of Africa. And
Right.
how does one address that question to Africans, in your opinion, urging them to commit to climate change at the same time that they are being so heavily damaged and victimized by forces that they can't control, directly at least?
Well, that's a very important point, Wolf. And I think the main thing that we need to say to people in African countries is we are sorry. We apologize for what we have done, and we apologize for what we are doing. And there are some of us in the industrialized nations that are working to reverse some of what we have done. And all I can say is I'm sorry. The other component of it, though, too, is, you know, what I was saying earlier. Every bit we emit matters. And so some people in the United States, they want to say, oh, well, China emits so much. Why should we worry about what we emit? And that's not a good reasoning. Every bit we emit matters. It's all additive. It all adds up. So we all need to reduce our carbon footprints. And we have a much bigger job in the industrialized nations than you all have in Africa because your footprints aren't as big as ours. And we're pushing our country to do more. And I hope we have greater success in the near future. So that's not a great answer, but all I can do is apologize. There's a question in the chat. What is the best way and method to collect, accelerate, and disseminate traditional farm-based experience based on your particular experience, and what is the role of digital technologies in bridging the gap between? A very good question, because that's kind of what we need to figure that out. How do we get the message out to people? I think the traditional farmers already know, and many of them, like in these seed schools, they already have a method for exchanging their understanding, and each one contributes a new pit of knowledge to the community's understanding. But now we have people who are trying to put in much bigger farms and much bigger agriculture using industrial agricultural techniques. That's one of the areas where the real challenge is. How can you get them to emulate what German farmers are doing rather than what United States farmers are doing? Because the German farmers are putting more carbon back in, and the United States farmers aren't. So there are many different components to the whole thing, and how to get more. I don't know how good internet connectivity is across Africa. You suggested that the role of digital technologies might help. It depends on how connected people are. I think campaigns, education campaigns about different agricultural practices. So if you're going to go to the bigger farms, model what the Germans are doing in their farms rather than what the United States folks are doing in theirs, because it's much better in terms of carbon footprint. So there are important aspects of that. And if you educate all the citizens, try to reach out to the big farmers and the small farmers, everybody. But the more people who know about this, the more likely it will be accepted.
Could I urge a comment in your opinion, Stefan? I noticed in one of the charts that which you were showing with the progress in Africa, that emissions from transportation were more or less constant, unchanged. In other words, they were not declining, and that's the CO2 emissions, and that relates to food production. And one of the key components of the cost of food, especially in the United States, in some cases over 90%, comes not from the agriculture production itself, but from the transportation of the product. And this relates to your agricultural method or system that you've arranged. And that might be an encouraging way to model the food production increasingly in Africa if you can avoid that transportation cost. Have any thoughts on that argument or?
Yeah, no, that's very important. Here in the United States, it's very important. And the way people are trying to address it here is by having what they call a farmer's market. And I'm sure these go on in many African communities already, and they're part of the traditional way of doing things. But in the United States, we are all so used to going to the supermarket, and that's where we get our food. So people are trying to bring farmers markets back in. The farmer brings produce to the town. The farmer lives nearby, so there's not a long transport. And those farmers markets get you healthier food. You can talk to the farmer, learn how they raised their crop, and so forth. And so they're good in so many ways. And so those are already happening in Africa. Maybe some of the big cities are now using supermarkets also. But in the big cities, they should keep the farmers markets going as much as they possibly can, because that reduces the amount of transportation footprint. We need to move to electrical tractors and trucks as well. So we can't just be changing our cars to electric, but also the farm equipment and the bigger equipment that's required. Ah, bonjour, je suis Emmanuel Wiza. My school language is French, but I don't know enough. If it was German, I could speak fluently, but I let's see. I'm sorry, I cannot understand enough to give you an answer. But send me an email, maybe we can translate our messages. Thanks for the link to the Association for Farmers. So Kaka Nadiradze has put in some links into the chat. Please, if you click on the links now, then you'll have the website open after we're finished. So thank you for adding those for us to explore. Emmanuel, from the Democratic Republic of Congo, based in the city of Goma. I am a climate activist and I carry out activities as part of the Plastic Free Fridays initiative in Congolese cities, particularly Goma and Bukavu. Very good. Thank you for your good work. How can our environmental movement work with you? We are active on the ground in the fight against plastic pollution on Lake Kivu. Well, that's where plastic pollution has some of the biggest impacts is in the ocean and in lakes and in rivers and streams. So thank you for your good work. We live in such dry habitat here that this is less of a problem for us. But we do have a group that is working to recycle more plastic and to get people to use less plastic. So we try to get people away from plastic bottles and to use reusable containers. So we do water bottles that I also use for tea and whatever I'm drinking. And the way this works in my mind is I see sometimes the students, they get a new water bottle every semester or every year or what too often. The best water bottle is the one that is the oldest because it means you have used less plastic for much longer, right? So we need to create new social norms of what is the best. Oftentimes people think, well, I buy the newest drink in the newest bottle and I buy the newest water bottle and things like this. So if we can change people's way of thinking about this, we can reduce our consumption of plastic. It's not an easy question. It's a big challenge to reduce our plastic consumption because so much plastic is built into the way we use products. But again, the traditional ways are cleaner. If we can find a way to get back to them in a way that still, feeds enough people and helps to build community. So, there are many benefits. World Farmers Market, thank you. So there's a good link about the World Farmers Market. Please take a look. Success in today's, thank you. So I put my email address on that last slide, but let me put it into the chat also so you can all have it. I might not have time to copy down everybody's email address, but if you send me an email, then I can respond and give you all my contact information and answer whatever questions you have.
Can I jump here?
This is my email address.
If
put it in the chat.
If I can jump in here,
yes, Ron.
Approaching the hour. First of all, Stefan, thank you for a tremendous informative speech. And for everyone, if you are signing either the Swahili petition, which I encourage you to, it'll allow us to be in contact with you to build an ever greater movement and a conference for next year as well. And the second thing is, we will be sending out most of these talks, including Stefan's talks, in the course of the next 2 weeks. It'll take a little bit for us to arrange them. And then the third thing, which we've been encouraging throughout these talks, is for you to review the idea of the story of self and even present your own short story of self of just 100, 150 words. And in most cases, because there are quite a few of you, the story of self will be published in the Friday for Future newsletter that goes worldwide. And we are encouraging you to understand what the story of self is that you can share, because the way we will communicate most powerfully is not just by the science, but what we've experienced in our lives that made us concerned about climate change. It's our story. No one can take it away from you, and no one can deny it, because you felt it not in your brains, but in your heart. So, in any case, Stefan, thank you for a wonderful talk, and all of you. And what I've understood now, for those who are there attending the conference, there's going to be a tree planting session. And then afterwards will be lunch. And perhaps, especially Newton can remain online here. And we may have a speech after lunch. It depends on the availability of the speaker. We're not sure at this point if they'll be arriving. If that person does not arrive and we do not have access, then the youth summit will be ending. But if that person does arrive, there will be another talk related to this called the circular economy. And she is an expert out of the Kisumu area. And I was just about to have her name, which is Askaniakawari. If I pronounced it right, I'm bad in Swahili or whatever it is. So in any case, remember there's something in the chat box to sign the petition in Swahili to endorse climate justice and peace, which is a requisite of our being able to compel slowing the climate change. So thank you all so much for participating in this event too. And thank you again, especially Stefan. So we'll stop here and then we will continue later. So especially otherwise, if Newton can come on, that's appreciated. And maybe Mary as well. Thank you all for this moment.
I thank you all for attending the session. To our amazing speaker, thank you for enlightening us. We hope to all of us, or few of us, will transform it into practical to make a tangible solution, as our slogan has been, and it will be. We say think global, act local. Those small actions that we make bring in momentum. That momentum is accelerated to maximum change. Thank you. I'll welcome Madam Mary to give a suggestion, and then we close.
Kwa sababu wana tagi kuna maana competition wana tagi, lakini kama tole na competition umemona ipija unapata nalo pata tema
au na riziki.
Hapana riziki.
To come on, please. Just begin speaking. We can see you well.
Oh, no, I was trying to wait for that person who was talking to finish. Okay, we were thinking like this. We are going for that tree planting, but it will take, we will finish around 2 p.m., then we go for lunch. Do you think it will be possible again to have another speaker from 2 p.m., let me say around 2:30?
If that person is available, I will announce it. I understood she is coming, but I haven't seen a confirmation yet. So
maybe she do like yesterday. So I was for the opinion, maybe if she has that presentation, then She can do it another time because as the situation is here right now, from a few minutes from now, it's going to be too noisy. We'll not be able to hear anything. Then from the tree planting, we'll be back here around 2:40, 2:30, which will be late for the speaker to do anything. I don't know how you can advise us there.
Yeah. And by the way, thank you all for those who are going to participate in the tree planting, and do take pictures, because we do intend to make a pictorial presentation of what has happened with many pictures, including of some of the speakers that we've had throughout the last 4 days.
Yes, we'll take photos, pictures.
Thank you, Mary.
Yeah.
And behind the scenes, I should point out a giant thank you to Kevin, Edwin, Mary, who have been very instrumental, and especially Mary, who has tried to hold all the threads together under extreme pressure. You are a heroine in this conference that made it successful, and thank you, Mary, so much.
Thank you too.
So at that point, we will end now, and I will let you know, or we will reestablish the talk on the circular economy, and we'll let you know. Thank you so much for.
Umeenda mzee amekuita.
Okay, thank you everyone for attending, taking your time, being part of this. Now it's time, now we have to go take care of Mother Earth through planting trees across some rivers here in Kisumu, River Uji. You'll see the photos and what that we are going to do. In case of anything, Sir Rolf, you'll just communicate, but that for now, community members are on the ground waiting for us. So we have to leave right now for the activity.
Thank you. Thank you all.
Bye.
Bye.
Yeah, bye. And thank you all for participating.
Thank you.
Bye. Thank you, Stefan.